Welcome! This is 7.1, Nth Roots and Rational Exponents. Our purpose in this section is to explore what roots are, to use some exponent properties, and also solve equations by using nth roots. So go ahead, pause the video, and really quickly try to solve the warm-up questions. Perform the indicated operation, and when you're done, hit unpause to check your answers. How'd you do? I want to look at number 2. So just quick reminder, if you have a plus or minus sign in the parentheses, you have to write it out twice and then FOIL it. You can only distribute the exponent if it's multiply or divide inside the parentheses. We're going to talk about that more as this year goes on. All right, square roots and other roots. The main question of this section is, what really is a square root, or what really is a cube root? So first of all, what does square root of 9 really mean? Well, what it really means is we're looking for what number squared would give us 9. So what number squared gives us 9? And the answer is 3. 3 squared gives us 9. Another way of thinking about it is a square root is looking for something multiplied together twice to get the number. Let's say I had a different type of root. This is called a cube root. This little number right here, that's called the index, and that tells us basically how many times I'm multiplying to get together a number to get the number underneath. So what could I multiply together 3 times in order to get 8 is basically what this is asking. And the answer is 2. 2 multiplied by itself 3 times gives us 8. Here's another one. This is the 4th root of 81. So this time the index is 4, and I'm looking for what number multiplied by itself 4 times would give us 81. And the answer is 3. Now, if you're trying to do this on your calculator, let's say I wanted to type in the 4th root of 81. Here's what I would do. In my calculator, I'm going to type the number 4. So I would go on my calculator and type in the number 4, and then I'm going to hit the math button. That is right underneath the alpha key on the left side of your calculator. And then if you look at this list that pops up, number 5 has something that looks like this. What's happening is the 4, the number you pressed earlier, is replacing the x. Now once you have that on your screen looks like this, and then go ahead and type in 81, and now when you hit enter, you should get 3. The next thing we want to talk about today is fraction exponents. So just a quick comment. We've talked about this in GO2, but if I have, for example, the square root of a times the square root of a, that is just equal to a. Now how does this translate to a fraction exponent? Let's say that a is really a to the first. Now the only way I can get a to the first is if I have 2 a's here, both with a fraction of 1/2 for their exponent, because 1/2 plus 1/2 is 1. So here's what I'm just showed you. The square root of a is a to the 1/2 actually. We can translate to that to other roots too. So the cube root of a is actually a to the 1/3 power. The 4th root of a is actually a to the 1/4 power. And you might not only have a number there. Well, let me give you the general term first. Here's the general term, a to the 1/n power. Okay, but let's suppose that I also have an exponent underneath with my m. The root number still goes on bottom, but this exponent now goes on top. So here's what I think about. Exponent goes on top, the root goes on bottom when I turn it into a fraction exponent. One more side note and then we'll get to some problems. Notice that the cubed root of -8 is possible because if I multiply together -2 times -2 times -2, it is -8. But I cannot take the 4th root of -16, for example, because there's no number I can multiply together 4 times to get -16. It would be imaginary, actually. And we're not really talking about that in this class right now. So in our minds, we're going to think not possible for that. All right, let's talk about some real nth roots. So if I'm going to find the roots of something, it's really kind of like you're solving an equation. And let's say that I have this going on right here, the nth root of a. So let's say that n, that index, is odd. If that happens, there is one real nth root. So if n is odd, there's one real nth root. For example, the cubed root of 8 is just equal to 2. So this was what I was looking for, the index. All right, now if that index is even and the number underneath is greater than 0, there will be two real roots. For example, the square root of 16, the roots are positive or negative 4. There's one thing we're going to add in the middle here that wasn't on your original sheet. If n is even and a is equal to 0, then the root is 0. So here's what this means. This makes sense if I write this out. For example, no matter what, the fourth root of 0 is 0, the square root of 0 is 0. Any root of 0 is equal to 0. That's what that's saying. And then last but not least, if n is even and a is less than 0, that means that I've got a negative underneath the root. The radical, that is imaginary. All right, here's the first thing we're going to do with this. We're going to find the roots of a. They're going to give us some information here. We're using the nth root of a. Okay, example a. N is 3, a is negative 125. Here's what I'm finding. You can use your calculator. Because n is odd, I go to back to my notes. Okay, n is odd, that means there's one real root. Oh, and the root is negative 5. That's it. Part B. N is 4, a is 16. So here's what I'm thinking. My index is even, and a is greater than 0. So I'm thinking there's going to be two roots, and the fourth root of 16 is positive or negative 2. Hit pause and try C and D. Unpause when you are done. C, your answer should be negative 2, and D, your answer should be 4. For C, it's an odd root. There's just one root then. And for D, it's an odd index. And so I only have one root. For C, I meant to say that it's an odd index.